Hello everyone. I'm a sinister murderer who's gonna kill you all before you even leave this video. Okay, come back. I'm not gonna kill you all. I was just kidding. How do you like my dramatic entrance, by the way? Anyways, back to the topic. Actually, what is the topic? Well, guess what? Today I'm gonna be explaining electromagnetic waves. What are these idiotic little complicated names that they give? Actually, I myself have no idea why they give such complicated names, either Latin or Greek, but we're not talking about that. What is this electromagnetic wave? What are these actually? Light. There's always light all around us. We can't see anything without the help of light because it goes and hits an object, reflects back and right into our eye, which is then sent by the nerves to our brain where it's processed, and well, that's it. We see things. So this is how light helps us. It helps us to see. Now, what is this light? We say light is made up of photons, and it actually has a wave-particle duality. It's something that is a topic for later in what I'll be explaining in a later topic in later videos. But for now, let me tell you, light actually has a wave-particle duality, which means that it acts as a particle and a wave. It has photons, which then also act as a wave. Now, they act as a wave, but what actually? So we all know that light, it travels at a speed of 300,000 kilometers per second, which is quite a lot if you tell me. Actually, I can't even walk for 2 miles without slowing down to a snail's pace, but whatever, that doesn't matter. What actually matters is how fast this light actually goes. So fast. And how does it go like that? That's because of a special theory of Einstein's here, but where space-time itself contracts and stretches. If you don't know what it means, I will film a video on that later. But for now, just hear me out. Its speed never changes, so that's light. 300,000 kilometers per second. Now, what is light? It's an electromagnetic wave. And what exactly is that? As I told you, that's our topic for today. So, atoms, electrons, protons, neutrons. These are all part of an atom. Now, the atom has subparticles like quarks and gluons and all kinds of weird thingies. And now what we're going to be focusing on is electrons, protons, and neutrons. What do these have in common? Let me know. There we go. They are all charged particles. Electrons have negative charge. Protons have positive charge. Neutrons have neutral charge. Like, you can say they have no charge at all. So, what does this charge mean? To understand electromagnetism, you must understand the basics. That is, what is charge? What in the world is charge? Where does this charge come from? It's not electricity. We know that. What is this? Charge. Actually, a charge is like, it's a fundamental property of matter itself. The electron, protons, and neutrons must have charge. It comes from quarks and gluons, which make up the protons and electrons and stuff. So this is where charge comes from. And according to the charge, it depends. The charge actually, let's say it symbolizes how that particle would behave in an electric field. Now, what is this electric field? Just pops up in your mind. Electric field, there's no electric coursing through a field or something. No. Electric field is the way a charged particle behaves around it. Just like how a mass is to a gravitational field or gravity, that's the same way a charged particle is to an electric field. Like for example, now if you have a mass, that will create a area that is what we call gravitational fields or gravity. That field, we call it gravitational field, because of the mass, that object, that particle. Now, when it comes to charged particles, they create an electric field. That is, for a proton, the lines of the electric field would go outward, and for an electron, the light would come from infinity to the electron. So this is how it works. Okay, so now we know what is charge. The next thing we're gonna understand is, why do protons and electrons attract each other, and why do the similar kinds repel? Now the thing is, they are both having those electric fields, am I right, as I told you before. So what is happening here is that when the same kind, let's say proton and proton, come together, the same kind of electric field causes it to repel, because since it's the exact same, just repels. And when there are unlike ones, since there's a difference between the electric field, it links together, it bonds. Now this is why it repels and it attracts. So that's how it works. Now let's move on to magnetism. What is this magnets? Magnets has a north pole and a south pole. It all depends on our magnetic fields around the Earth. Now what is this? What if we split the magnet into half, like the north side and the south side separately? What will happen? Even then, despite that, they would get a north and a south. The split parts themselves will have a north and a south. Despite splitting it 100,000 times, you still have the same result. Each bit of piece would have north and south. So why do magnets repel and attract? Is for the exact same reason. The charged particles repel or attract. But the charge of a north and a south linked together, it cancels out both of their charges. So that's why nothing happens to them both. And that's why it pops up even if you divide it. Now, so we've understood what is this charged particles and what is an electric field. Now we've understood what is magnetism. Now on to a famous experiment done by a Danish physicist called Hans Christian Ørsted in 1820. Okay, during that time, he was playing around with the compass, and there was a wire right next to it. Right by him. So he put a active wire right next to the compass, and for some reason, the compass needle started deflecting. That's weird. Is something gonna happen? Earth's magnetic field is gonna completely flip. The ocean's gonna come to the land. The land's gonna go to the ocean. Nothing was happening. It's just physics. The compass he was holding was deflecting because the electricity is made of moving electrons. When electrons move, not only electrons, mostly they use electrons, but when charged particles move, they create electricity. So when electricity is created, when charged particles move, they also create magnetic fields around them. So since there was a magnetic field interfering with the magnetic field that the compass is pointing to, it started deflecting it, since it was near those moving electrons. Now, this is the amazing fact that we've learned, that when electrons move, they generate electricity and a magnetic field around them. Now you understand completely what this is. Perfectly good. Thank you. I'll see you next time. I hope you subscribe for more content. Bye.